Okay, back with this beast. I had mentioned previously that the tremolo circuit wasn't not working. It's not rocket science, that one. Well, actually, none of this is really, but one of the problems was I forgot that you have to have the pedal plugged in and switched on. The tremolo will not function without the pedal plugged in. And the reason for that is, put simply, without this plugged in and shorted, there's a line to that circuit that gets connected to, of all things, that negative DC bias that's used for the output tube grids. That feeds part of the tremolo circuit that is the oscillator. And with that minus DC, with that negative DC potential applied where it is through a resistor, in that circuit stops the oscillator from oscillating, which means the neon lamp is just off. And the only way for that oscillator to function is if this node is grounded through this foot switch. I'd forgotten about that. But nevertheless, it's still not wobulating. The oscillator is oscillating. Okay, I can see it down here. Right here is the photo coupler. If you like, photo isolator. It's a neon lamp real close to a photo cell down in there. It's got what appears to be shrink wrap on it. Likely is. What goes wrong with these, especially if in high humidity, is the photocells give up the ghost. I can see, and maybe, hopefully, you can too. I kept there's low lighting in here. Maybe you can see some flashing coming from here. Do I have a? Yes, I do. Just a piece of paper here to bit reflection. Maybe you can see that pop, 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 pop. So the oscillator is working, and so is the neon lamp being driven by it. And if I change the speed setting for the tremolo, that of course will change. It's set to the lowest speed setting right now, which tends to give the brighter flashes, by the by. So the oscillator's working. I've poked around a little bit through the intensity control, which is tied in with the photocell end of this thing. And I'm not seeing any change, or so tiny little bit of change in resistance of the photocell by that pulsing of that neon. So that needs further exploration. So I'm gonna put some more light on things. I was hoping with this sort of dimness you might be able to see that neon was flat. Okay, that looks like you can see. Okay, yep. Got this super high-tech meter here. The reason I'm using that, well, it's my garage meter. I think it was made by Micronta or something. But this branded Sears. I would say that was one of my cats, but no. I'm going to have to check on that, find out what she wants. But anyway, just chose this because it's easier to see certain sorts of signals with one of these analog old school meters Um, and if I do something wrong with it, it goes, who cares? Um, Actually, these are getting a little hard to find. It's probably not a good idea to Zorch it. So, first thing, I'm going to set this to read the volts, 250 volts full scale. And we'll look at what's going on with the neon lamp. Now there's pulsation there, and it's going to be DC. Let's swap the polarity for that. Okay. So, I don't know if you can see, it's a fairly low voltage. I'm going to go down a range. Now, you should be able to see, look. Yeah. We'll see. Now, in any event, trust me, you can clearly see that, I can clearly see this needle bouncing around, and that's because the voltage across that neon is up, it's a sine wave across it. And so, I'll disconnect that from there, and let's, now, we're not looking for voltage here, we're looking for resistance. Oh, by the by, there is only one tube in here, and that is the tube that its only job is the tremolo circuit. It's a twin triode, two separate elements, two separate tube or valves in one envelope. Half of it is used as the actual oscillator. The other half of it is used as a sort of buffer between the oscillator and the neon. Not sure why they did that. It's not necessary. I built this oscillator and with the neon, and it works great with just using half the tube. I suspect it was because they had to have the tube anyway. Why not use the second triode in it as a buffer? They may have had other reasons I'm not aware of for doing that, but nevertheless. Set this to read resistance times 10K, so full scale, this thing craps out about 2 megohms. I'm sorry, 20 megohms. Not a vacuum tube meter, so yeah. Judge at your own risk. And I'm going across the photocell in there. That's not moving at all. Now, you must bear in mind that this is also associated with the intensity control. And as I turn the intensity down, it's cutting that off down to, well, let's see, what is that? It's pretty low ohms. Well, whatever the bottom out resistance is of this pot. Anyway, with this all the way up, that's a 50K pot, and it's reading a little bit less than that. I'm sorry. Damn it. I bumped into your leg again. Your leg's very close to me here. And so is stupid traffic. But anyway, I'm not seeing any wobulation there at all. Nothing's moving. Not an unknown trouble with these particular photocouplers, optical isolators, if you like. And so that's going to have to be, I'm going to have to pull that and replace it for this to work. Thinking maybe. Yes, I'm thinking definitely. Do a little bit of demo of what that is. It's got to come out anyway. And other tests be done. So yes, I'm gonna suspend this right here and prepare for the next step. There. Okay, I have removed the suspected failure. As I said, the neon lamp in there is working. I'm almost certain that cadmium sulfide photocell photoresistor is just foobar. Humidity got to it. Not uncommon. You can get replacements for these. They're not cheap. But you can also make them and find them in other places. Anyway, what I've done is I've pulled that part out and I've replaced it, for now, just tacked in, just for grins and giggles, a photocell. This is a hermetic sealed one, so humidity's not going to bother that one. And this is just an NE2 lamp. Might be an NE2H, doesn't matter. It's a neon lamp. Pretty much what's inside of this thing. Only they didn't use a hermetically sealed photocell, the photoresistor. Got the lights off again, so you may see this flashing. It should be, I'm sure it will be obvious. Power's off right now. Full up. And within moments, this should begin to flash. It'll do that, and then wop, 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 pop, 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 pop. There it is. That part of the circuit's working just fine. And it already showed that. But what they do, what's in this little package here, is just this, sitting in front of this. Now I have to be careful here. I am sitting on a concrete floor, and there are some voltages on some of this. What I'm trying to do is position this neon close to the window of the photocell, the photo resistor. Oh, come on. That should be close enough. Alright, so flash, 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 flash. And let's see, where's the speed control? There it is. You can see what happens to it. It's just changing the rate, the flash rate of that neon. That's the fast as it will go. The camera frame rate may be causing this to strobe a little bit, but it's flashing like down to bang, 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 bang. So is the photoresistor seeing that? Maybe a little hard to tell because there is some ambient light in here. And we'll set this to read ohms. Well, it is wobbling a little, but there's quite a bit of ambient light in here. Let's turn this, let's block some of that. I gotta be careful with this. Oh, looky there. Yeah, the ambient light's getting to it. So, point being, the photocell shot in this in their optocoupler. Give you an idea. Let's see. I'm going to put pardon me, bright lights on. And the resistance of this photocell's gone way, 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 way down. 5K or so. Let's see, 10 times 10K. Yeah, about 5K. 5,000 ohms. exposed to quite a bit of light. And this isn't sunlight, but that's 600 watts of stage lights. I'm going to take this piece of heat shrink and cover this photocell. That's dropping down between 50 and 100K, somewhere in there. So it's quite a bit of a resistance change. And actually, that photocell, that photoresistor by itself, drops down to way below, much more resistance than that. It gets down into the 20, 30 megohm range. What we're looking at right now is the intensity control. Set at maximum. It's a 50K pot, so that's to be expected. But that the light from this neon impinging upon this actually does affect a change where it's supposed to. This tremolo circuit's going to work. Now, I can make one. I could just couple this with this and put it in some shrink tubing and tie it in there. That's one option. I'm almost... I'm going to open this and hopefully show you what the thing looks like inside. I'm not entirely convinced how I'm going to approach this. I do have others already made up. These are used from something. It's been long enough, I do not recall what these came out of. I've got a number of them, a couple of different manufacturers. Let's see, these are interesting enough to explore. Let me turn this off where I zap myself. It says on their photocell lamp, and one end is a neon lamp just like this, and in the other end is a photocell. Not as a high a quality one as this one, but better quality than what Fender had put in here. I suspect they had ladies on the factory floor making these things. It's just shrink tubing wrapped around the photocell or photoresistor and a neon. Now, these are a bit more rugged. I believe that's an aluminum tube. I don't play around with it, but this is going to work again. But I just thought I'd go over a little bit of illustration of what actually is going on with this. So the tremolo oscillator just winks this bulb. It's wink rate controlled by a front panel control, in the speed control, and the light from that is seen by a photoresistor, and that biases the phase inverter, phase splitter, somewhere in the middle of the amplifier. It causes it to change volume in accordance with this blinking. That's all it is. And the photoresistor in here is foobar shot. I think I will. I think I will just put one of these in there, see if it works. And if it does, hoo-ha! And I'm pretty sure it will. But we'll, I'll prepare for that. I won't bore you with soldering. In a minute, just in a flash. Okay. I took out the discrete neon lamp and the discrete photoresistor and went ahead and just dummied in one of these prefabricated ones. I've got them, why not use them if it works? It powers off right now. Measuring across one of those, let's see, grab a different one here. This arrow, by the way, it points input, output being the photocell, input being the neon lamp enclosed within this molded affair. The photocell, resistance-wise, reads. Let me zero this thing. Sorry about that. So that's a dead short. This is the photocell in darkness. Yeah, it's not going all the way down because the meter's tilted back, but suffice it to say that that's very, very, very high resistance. It's up around 20 megs at least. See, I pick another one of these at random. This is a different manufacturer. Looks like Yokohama. This is the photocell side. Again, very, very, very high resistance. So on this Sears meter, it doesn't even show up. The other end of these is just a neon lamp. It's just going to be open circuit to this voltage. So that's what's in there. But watch now. This is in circuit, and across this, or involved with it, is the intensity pot. I've mentioned it before. It's 50K, or supposed to be a 50K pot. It's reading a little bit higher than that. I don't have the paper schematic right in front of me, but this control, you turn all the way down, you get very low ohms. You turn it up, well, there's 50K right there. So it goes a little higher than that. Essentially, this is across it in circuit. So it powers off right now, so that neon lamp inside of this coupler is not lit. That oscillator, it takes as the tubes come up, or in this case tube comes up, the oscillator will at first just put a steady DC voltage across the neon, current through the neon, and as its gain increases, as it warms up, it will begin to oscillate and the neon will flash. That should be visible here. We're looking across the photocell. Should be. Not terribly, but if you see it on this meter, chances are in circuit, once we get her turned over and plug all the tubes back in, the wobulator will wobulate, and then we'll have tremolo. So power up and watch. This right now, neon lamp in the photocoupler is not lit. It will come on steady, and you'll see this resistance drop. There it is. Gets very low. Then it will begin to wobble, which it's doing. I don't know how, if it's kind of subtle. I don't know if you're going to be able to see it there, but that needle's bebopping around. So it decreases the resistance of this circuit quite a bit, and I guarantee you that's going to make this thing this may not be the best combination. Neon, the neon in these things they're all pretty much the same. I don't know what photocell is in here, but it's awfully doggone similar to others I've seen in this application, so I'm going to leave that tacked in for now and move on to other stuff. I already know the amp works. I have gone through and cleaned some of these potentiometers and some of these controls, or phone jacks. The number one normal input phone jack is kind of bagged out. With nothing plugged into it, it is not grounding the input. That's not supposed to be. It's just bent. Somebody's either been in here or I don't know. sometimes if you trip over a chord, they can do this. Now that's easily remedied. But I'll get around to that. So what's next then? Flip her over, put some tubes back in, see if the tremolo functions, that, and then have a look at the reverb circuit some more. Sneak preview, yeah, I did, the reverb pan in these amps is mounted in the bottom. I have it here, I've taken it out. I measured, I was looking for continuity. It has an input and an output. Think a speaker and a microphone, like that. And typically those two measure about the same DC resistance. So I measured one, it looked good. I measured the other one, open circuit. Oh, no, 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 no. No. So that I pulled the tank out and got nitty-gritty with it. It turns out there's nothing wrong with the pan. It's, well, I'll show later, but as far as the coils go, thank you, Lord, those seem to be in working condition. I thought, well, maybe the cords they use, which are, by the way, the two coax cables leading from the reverb pan up to the amp chassis, are not original. They've been replaced. Somebody's already been looking around in there. But anyway, the reverb pan appears, the reverb tank, if you like, appears to be functional. We'll know shortly once I get this thing turned over, put some tubes in it, we'll check out to see if the tremolo works. Whether or not that works, we'll just carry on with seeing if that reverb tank is working. The driving circuit notwithstanding, we can still determine if that tank is any good. Looking at it, I say it is. Resistance measurement says yes. Visual inspection says yes. So, well, we'll worry about that in the next clip. I might make this number 5 and then start at number 6 just for the purposes of brevity. We'll see. See it. Okay. Or as they say, okay. Turned over. Plugged in the speaker. I've also plugged in the tremolo enabler pedal. Obviously put tubes back in. There's only one missing. That's reverb driver tubes. Not in. We'll get to that momentarily. So power on. And already mentioned one of these input phone plugs or jacks is not grounding without a cable plugged into it. That could be a source of some noise, hum. Especially if this is turned up. If it's turned down, you know, I can hear the tremolo oscillator ticking, which is common with these from what I've read. It must be the reverb one. What's this? Yeah, no more ticking. There's some noise, and we'll get to that. I'm terribly worried about it. I think there's probably a noisy resistor somewhere. We'll find her. It. Okay, so let's see. Got my guitar still here. It's going to effects 1. Oh, I can already tell that. working. The tremolo is working. Yeah. Weird feedback with that ballast. That could be useful, right? Yum yum. So, I did take some time and clean the pots. Maybe I've mentioned that earlier, a little bit earlier. I did do that, cleaned all the things. That's where I noticed this one input phone jack is a little screwy. But take a look at that, tremolo's working. All the way up. Let's see. Random chords, but clearly tremolo's working. Okay, that optical coupler isolator, if you like, I've probably had for 20 years, 25 years, won't fit just perfectly here. So it stays. Yeah, that's going to stay. Now we have this reverb tank. Got it here. It's mounted into the cabinet this way. There's can't really see well here. It's there's the output, or at least it says output, and this says input. Now, if I'm the reverb tank maker, I'm going to say, well, this is where you put the signal in, and this is where you get the signal out. But there's often confusion about that. And this tank sits in a bag down in the bottom of the cabinet. And to the bottom of it, of the tank, is mounted this. Take a quick look at this. It's a piece of corrugated cardboard with two rails, strips of wood, onto which this tank is screwed. There's mildew all over the place, this dust stuff. That's got to be cleared up before we reassemble anything there. The pan itself, I'm just going to set this here. And you see some noise coming through. I have to find the source of that. Anyway, this tank is in, I call, pretty fair condition. Not good, but useful. These springs that attach the actual reverb unit are all there intact. The actual reverb springs, the tank itself, themselves, are both there, intact. They're not there's no corrosion on the inside of this. There's some rust on the steel housing, but there's no corrosion on either of these. I noticed they are different, these coils, so it does matter which side you drive and which side you pick up on. I'm calling input the one you drive, and output is the one you connect to the input to the amplifier. So I'm sure that's information about that is available. Resistance measurements on both of these coils, the pickup and the speaker coil, are essentially the same. 171 ohms on the input one and 178 ohms on the output one. I'm going to make an assumption that the input one is the one that's driven, and the output one is the one that feeds into is the driven is driving the input stage of the amp. We'll see. For some reason, these use different the RCA connections to the this one to the what is it? The output. That one has no connection to this chassis, this can, electrically, while the input one does. That would make sense. You don't want ground loops and so forth, so only one end would be ground. It makes sense that it would be the input side. So, oh geez whiz. Now there's always a question: input? No. Input to this or input to the amp? Oh, good grief. Yeah, we'll work it out. I'm sure these details are available. But anyway, we can't drive this because the driver transformer's shot. But we can see if this thing has any pickup at all. Now, let's take a wire here, plug it into what they call reverb output. Turn the reverb volume up. That might be it. Don't feel like it. Oh, maybe it is. Oh, this cord's a little dodgy. Okay, so this is labeled reverb output. Okay, so there's something there that says reverb output. Well, I think that is the output from the reverb tank. Interesting. Oh, I know why that is. Maybe they are the other way around, because this is not shielded and we're connecting it to an input and capacitively coupling it to all kind of crap. Let's see. Yep. can't see what's on these knobs. That popping is the springs touching the grounded case, I'm pretty sure. Oops. Turn the volume down. Oh, yeah, that's not going to feed into this. No. No input to it. But this pan seems to be working. This tank, rather. What? I'm gonna ground. It's already grounded now because of this RCA being plugged in, but I'm gonna otherwise ground it so that we can plug into the other end without the squealing. And something else might not be quite. Yeah, hush. I'm not finished with you yet. That should be louder. Have you ever had one of these and you bump into it? Ba-dang, 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 ba-dang. It's not doing that. Uh-oh. What was that? What? Uh-oh. Off. Something changed. Ooh, we gotta go back a step or two. Alright. Off with this right now. This is why we put ballasts. Don't need this right now. Anyway, I think that just... The reverb tank is not blown out. It's, it's going to work. I'm going to put fire to this. It might have just been... I don't know. Oh, there it is. RFY. Oh, that's because I let this cord blow down. My bad. Yeah, there's still some, I did tighten this down. There's still some other minor issues with this, but okay, so the reverb tank is functioning. The tremolo is now functioning. It's pretty obvious why that was not. And I really would like to get the reverb functioning in this, at least somewhat. That's going to involve a bit more of a closer look at this. As it is, I have a small transformer. This is not built for this application, but it may work, just if nothing else, just a test. But from what I'm saying, that reverb tank is functioning. The only thing wrong is might need to replace this tube socket, and boy, that's really microphonic. What is going on? this one, this tube. Interesting. That's the RCA 7025. That one, yeah, that socket's a little dodgy. The tube itself too is, no matter where you put it, it does that. I would expect a little bit of that from the very front ends, but this one, yeah, not so much. That tube's got to go. Oh yeah, this is Mr. Microphone. Yeah, so he's got to go. I got one laying around somewhere I'll put in. I think what I'm going to do is pop in a tube into this. I mean, why not? It's got nothing to lose. It's not going to hurt anything here. Maybe tack this in. And see if we can make something come through the reverb tank. I'll mull over this a little bit. This is a little power transformer. It has something like a clock radio. Has a 120 volt input and probably 6 or 12 volts, maybe 9 volts output. This could, at least as a test, function as a matching transformer here. We'll see. We'll play around with it. There ain't no rush. She's working, and right now better than it was an hour ago. That's it.